Equation of a straight line with coordinates is what we're looking at in this video. So it's split into 4 parts. In part 1, we're looking at examples like this. Which two of these lines are parallel? And in part 2, we're looking at examples like this. How do you find the equation of a line passing through a coordinate given a gradient like that? And then part 3, we're looking at examples with 1 and 4 quadrant graphs where we've been asked to find the equation of a line given a point and a line. And finally, we're looking at examples like this where we need to find the equation of a line given 2 coordinates. So the way my videos work, I'm going to do the example on the left, which is I do. You are then going to press pause and have a go at the example on the right, which is you do. Okay, so here we've been asked which 2 lines are parallel. Okay, now with parallel lines, if I just write down the equation of line, y is equal to mx plus c, they both have the same gradient. So the gradient is the term next to the x. So I can see the term next to the x for these 2 is the same. So my answer is that one there and that one there. Those 2 lines are parallel because they have the same gradient. Okay, and I've highlighted the gradient in yellow. It's 2 in both of them. Now hopefully you've pressed pause and had a go at the example on the right. So with this one here, the answer is going to be that one there and that one there because they both have the same gradient. So the gradient is the term next to the x. So here's some practice questions. Press pause now and have a go. I'm about to put the answers up now. So here are the answers. Mark your work. Moving on. So again, same question, which 2 lines are parallel? So a little bit trickier now. Again, if you look at the x terms, working our way down, so we have the x term there, 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 and there, and the 2 that are the same are these 2. They both have a -3, okay? Don't confuse it with this one. So my final answer, if I just use my highlighter, is that one there and that one there. Again, hopefully you've pressed pause and had a go at the example on the right. So you're looking at the x terms. So if I just underline them, okay? So if I look at all these x terms, there's 2 that are the same. So that is going to be this one here and this one here. They are both -2. This one here is a +2, okay? So my final answer, if I highlight it, is that one there and that one there. These 2 lines are parallel. So moving on, again, we've been asked which 2 of these lines is parallel. Now looking at this, you might be tempted to say, well, actually, it's that one there and that one there. And the reason that's not quite right is if I write down the equation of a line, y is equal to mx plus c, and you see the problem there, that's 2y. So firstly, we need to get rid of that 2. So we can say this is y is equal to, if I divide each side by 2, 4x plus 2. So what I've done here is I've divided this by 2 and this by 2 to get the y on its own. And now if I compare it, so the 2 lines that are parallel to each other are that one there and that one there, because this can be written like this in standard form. Okay, so that is my final answer here. So whenever you get something in front of the y, you want to get rid of that. Okay, so again, press pause and have a go at the example on the right. So hopefully using the advice I gave you, the first thing you did is get rid of these 2. When I say get rid of, I mean get rid of the 4 and the 6 on the y. So that would be y is equal to 3x minus 2. And this one here would be y is equal to 3x plus 1. So the 2 with the same gradient are actually that one there and that one there, because they both end up with a gradient of 3 and 3. So here's some practice questions. Press pause now and have a go. I'm about to put the answers up now. So here are the answers. Mark your work. Moving on. So here we've been asked to find the equation of a line which passes through that point with the gradient of 3. So if we go back to what the equation of a line is, that is given as y is equal to mx plus c. Now they've told me what the gradient is, so let's put that in. Y is equal to 3x plus c. Okay, so the only thing I need to find to solve this question is that there, and I've solved it. Now the way I can do that is using this point here. So with this point, I know that x and y coordinates have been given. So if I put this x in there, and if I put this y in there, if I substitute them 2 in, I can find c. So if I do that now, so y is 5, and x is 2. So all I've done is I've substituted this one into there, and I've substituted this into there. So that's saying 5 is equal to 6 plus c. That means c is equal to -1. So my final answer is y is equal to 3x minus 1. Okay? So hopefully you've pressed pause and had a go at the example on the right. So we have y is equal to mx plus c. The gradient is 5. And to find c, we're just going to substitute these 2 points in. And that is the answer there. So moving on from there. So again, the exact same approach here. So we've been told, find the equation of a line that passes through that point and is parallel to the line y is equal to 2x plus 1. So if I write down the equation of a line, now I know the gradient is going to be 2. And the way I know the gradient is going to be 2 is because it's parallel to this line. If two lines are parallel, they have the same gradient. So that means the line that we have, that we've been asked to find the equation of, will have the same gradient. If I just highlight that, it'll have the same gradient as this line. So straight away I know what the gradient is. And now to find y, we do the same approach as before. We substitute them 2 points in. Y is 9, x is 2. So that is 9 is equal to 4 plus c. So that means c is equal to 5. So my final answer is y is equal to 2x plus 5. And like I said, you'd notice both these lines have the same gradient because they are both parallel. Okay? So hopefully you've pressed pause and had a go at the example on the right. The gradient is 3. And if I substitute in the x and y values, that would be 3 is equal to 3 bracket 4 plus c. So that is 3 is equal to 12 plus c. And c is equal to minus 9. Y is equal to 3x minus 9. Okay, that is the final answer there. So here's some practice questions. Press pause now and have a go. I'm about to put the answers up now. Here are the answers. Mark your work. So moving on. So we're just looking at some slightly trickier examples now. So the coordinates are going to be negative and the equation might not be in standard form. So if I look at this one here, we have y is equal to mx plus c. And we know that it's a parallel line. So the gradient is going to be the same as that one there. And now it's just a case of substituting these 2 points in. So minus 3 is equal to 3 plus c. So that means that c is going to be equal to minus 6. So my final answer of y is equal to 3x minus 6. And again, hopefully you've pressed pause here and had a go. So this time the gradient is negative 4. And if I substitute the points in for x and y, that'll be minus 5 is equal to minus 4 times 2 plus c, which is minus 5 is equal to minus 8 plus c. And if I add 8 on each side, that gives me a 3. So y is equal to minus 4x plus 3 is your final answer there. So looking at this one here, now it is a parallel line, so you might be tempted to say, well, actually the gradient is 12. The trouble is that bit there. Okay, remember the standard form is y is equal to mx plus c. When there's something in front of the y, like we've got 3y here, we want to get rid of that 3. So if I divide each side by 3, I get y is equal to 4x minus 2. So now I know the gradient of the other line is going to be 4x. So well, 4 is the correct way of saying it, I guess. So y is equal to 4x plus c, and now I just substitute these two in. So negative 9 is equal to 4 negative 2 plus c, which is negative 9 is equal to negative 8 plus c, which means c is equal to negative 1. So my final answer is y is equal to 4x minus 1. And again, hopefully you've pressed pause and had a go at the example on the right. So you should notice the equation is not written in standard form. So I'm going to move that over. So that means minus 2y is equal to minus 2x plus 8. And if I divide each side by 2, I get y is equal to minus x plus 4. And I've still got the negative on the y. So to get rid of the negative on the y, I can multiply each side by negative 1. And that would give me x minus 4. So I know the gradient is just going to be 1. And all I need to do now is find c. So I'll substitute the coordinates in. And that is 5 plus c. So that means c is equal to negative 9. So my final answer is y is equal to 1x minus 9. So here's some practice questions. Press pause now and have a go. I'm about to put the answers up. So here are the answers. Mark your work. Moving on. So here we are looking at an example where we've been given a line in green and we've been given a point and we've been asked what is the equation of a line which passes through point B and is parallel to the green line. So we want the equation of a line. So there's a line that's passing through this point and it's parallel to that one and we want the equation of it. So we can say y is equal to mx plus c and the gradient is going to be the same as the green line. So if I find the gradient of the green line, which I can do by picking 2 nice points on this line. So that would be 5 across and 2 up. So I can say the gradient of this line is 2 over 5x. So the way you find the gradient is you pick 2 nice points, you draw a triangle like I did there, and you divide the height by the width. Okay, so that's 2 divided by 5, that's your gradient. And now to find the y-intercept, all we need to do is substitute the coordinates of this point in. So the coordinates of this point are 6, 4. So y is 6, well, x is 6, y is 4. And I can say y is 4, x is 6, plus c. And we can say, well, that is 12 over 5 plus c. And if I do 4 take away 12 over 5, that gives me 8 over 5. So c is equal to 8 over 5. And we can then say that is going to be y is equal to 2 over 5x plus 8 over 5. That is our answer there. So hopefully you've pressed pause and I got the example on the right. So y is equal to mx plus c. Since this line is parallel to the green one, they have the same gradient. So I find the gradient of this, pick 2 nice points, draw a triangle. That is going to be 2 across and 3 up. So the gradient is going to be 3 over 2x plus c. And now to find c, we just substitute these coordinates in. So in this case, it is 6, 6. So 6 is equal to 3 over 2 times 6 plus c. And 6 times 3 over 2 is just 9. So 6 is equal to 9 plus c, which means c is equal to negative 3. So my final answer is y is 3 over 2x minus 3. So just a quick tip here in terms of whether the gradient is positive or negative. So you can just do something like this. If you draw them 2 lines on there, you can see this looks like an n. So this is a negative gradient and this is a positive gradient. Okay, so you can just do that little trick. Whenever you see a line, just draw these 2 vertical lines next to it. If it looks like an n, it is a negative gradient. So the reason we did that is because this next one, funny enough, is a negative gradient. So looking at this one here, we have y is equal to mx plus c. Now, since the 2 lines are parallel, the gradient's the same. So I'll find the gradient of this line. It's 2 across and 4 down. So I know the gradient is 4 divided by 2, which is just going to be 2. But in this case, because it's going down, it's a negative 2. So now I know what the gradient is. All I need to do is find the y-intercept, and I can do that by using these coordinates. So that's 6, 5. So x and y. So against 5 is equal to minus 2 bracket 6 plus c, which is 5 is equal to minus 12 plus c, which means c is going to be equal to 17. Okay, so my final answer is y is equal to minus 2x plus 17. So again, hopefully you've pressed pause and had a go at the example on the right. So with this one here, we are going to start off by finding the gradient. So if I just pick 2 nice points and draw my triangle, that is 2 across and 1 down. So that means the gradient is 1 over 2, which is a half. However, because the line's going down, it's a negative gradient. And now all I need to do is find c. To find c, I just need the coordinates of this point, which are 6, 6. So I'm just going to substitute that in here. So 6 is equal to minus 3 plus c, which means c is equal to 9. So my final answer is y is a half x plus 9. So here's some practice questions. Press pause now and have a go. I'm about to put the answers up now. So here are the answers. Mark your work. So moving on, we are now looking at the same concept but with 4 quadrant graphs. So now you notice the graph actually has 4 quadrants, but the exact same principle applies as before. Okay, nothing different. So we have y is equal to mx plus c. So because the green line is parallel to the other line that passes through the point, we know they have the same gradient. So you pick 2 points on here. We go across by 1, we go up 2. The reason we go up 2 is because we go from 6 to 8. Okay, we're not counting squares here. We're actually counting where we're starting and where we're going to. So the gradient this time is 2 over 1, which is 2x. So all I need to do now is substitute these coordinates in. So that is going to be 2 and negative 2. So negative 2 is equal to 2 bracket 2 plus c. Negative 2 is equal to 4 plus c. So c is equal to negative 6. So my final answer is y is equal to 2x minus 6. Okay? So hopefully you have pressed pause and had a go at this example on the right. I should also mention I have linked these worksheets down the slides, sorry, down in the comments below. So if you do want to print them off and work with me, you can do. So if I pick 2 nice points, so that there, draw my triangle, that's 2 and 6. 6 over 2 is 3, so that's 3x plus c. So that's the gradient done. All I need now is the y-intercept, which is c. And the way I get that is from this one here. So 3 across, 2 up. So x and y. We can say 2 is equal to 3 bracket 3 plus c. 2 is equal to 9 plus c. And we can say c is equal to negative 7. Y is equal to 3x minus 7. So moving on. So here we have got a similar concept. So again, y is equal to mx plus c, finding the gradient of this line. So pick 2 nice points on here, draw my triangle, 2 across, 2 up. So that's just going to be 1x. And to find the intercept, I'll just substitute these points in. So that's going to be negative 1 and negative 2. So x and y. So negative 2 is equal to negative 1 plus c. So that means c is equal to negative 1. So my final answer is y is equal to x minus 1. And again, hopefully press pause. And in fact, that should be, yeah, no, that is fine. And y is equal to mx plus c. So for the gradient, 1 across, 1 down. So if y is equal to, this time the gradient is negative. So it's going to be negative x plus c. And if I substitute the coordinates in, that's 1 and 6. So x, y, that would become 6 is equal to minus 1 plus c. So c is equal to 7. So my final answer is y is equal to minus x plus 7. So here's some practice questions. Press pause now and have a go. Here are the answers. Mark your work. So looking at this question here, we've been given 2 points and been asked to find the equation of a line that passes through these 2 points. Okay, now the way we do that is we have the equation y is equal to mx plus c. Okay, and we start off by finding the gradient. So to find the gradient, I'm going to show you an approach that would work on slightly harder questions as well. So to find the gradient, you just take away the y coordinates. So we can just say that we're going to take away the y coordinate of b from the y coordinate of a all over the x coordinate of b, take away the x coordinate of a. Now you could have done a take away b, that's fine, but you just have to be consistent, okay? If you started with b here, you have to do b here. And if you had a here, you have to have a here. Now you could have done ya take away yb, but then you would have to do xa take away xb, okay? You pick a point and you take it away from the other point. What you can't do is have a here and then b here, and then that doesn't match up with the letters there, okay? So we're going to take away this point from that one. So xy, so that would be 9 take away 0 over 5 take away 0, which is 9 over 5. So that's the gradient done. And to find the y-intercept, we just write y is equal to 9 over 5x plus c. We just substitute either one of these points. So you can pick either point A or B and substitute the x and y coordinate in. So I'm going to pick that point there. If I substitute 0 in there and 0 in there, I get c as 0. So my final answer is y is equal to 9 over 5x. Okay, so hopefully press pause and add the example on the right. So to find the gradient, we are going to take away the coordinate for y from, now it's up to you, you can either do b from a or a from b. So we'll do a from b this time. It would work either way, you would get the same answer, and I'll just show you that. But again, remember, on the bottom, you have to do the same thing. So I decided to take that away from that. So my answer here would become yx and yx. Just write that down. So it'll be 0 take away 10 divided by 0 take away 6, which is 4, because the negatives cancel out. And you would get the same answer if you did it the other way around. And so that is y is equal to 4x plus c. And now I just substitute either one of these 2 coordinates into there and there. So I'm going to pick this one. I'm going to put 0 in there and a 0 in there. If I put a 0 in both of them, I get c equal to 0. So my final answer is y is equal to 4x. Okay? So looking at this next one here, again, the exact same principle applies. You pick a point that you subtract the other one from. So I'm going to pick b. So that means my gradient is going to be yb take away ya over xb take away xa. And down here, that's going to become, we have xy and we have xy. So that's going to be 10 take away 4. Now careful here with the negatives, yeah? That is a negative 4 down there. So that's how we write that in brackets, okay? And xb is going to be 5 take away 3. Now the top here, that's a negative and a negative. That becomes a positive. So that turns into 14. And at the bottom, 5 take away 2, 3 is 2. So that's 7. So your gradient here is 7x. So we can say y is equal to 7x plus c. And all you do now is pick either of these 2 points and substitute y and x in there to get c. I'm going to pick this one because they're both positive. So that gives me 10 is equal to 7 times 5, which is 35 plus c, which means c is equal to minus 25. So my final answer is y is equal to 7x minus 25. Okay, that is my final answer there. And again, hopefully you've pressed pause and had a go at the example on the right. Now with this one here, I'm going to take away that coordinate from that one. Now you can do it the other way around, you'd get the same answer. So that would be, write that down, y, x, y. So we can do yb, take away y coordinate of a, x coordinate of b, take away x coordinate of a. So yb would be 12 take away 2 over 1 take away 7. That would be 12 take away 2 is 10. 1 take away 7 is negative 6. So the gradient here is negative, and you can see the lines going down. So that's going to be negative. If I half that, that's 5 over 3. So that's my gradient. And I'm just left with the y-intercept now. So with the y-intercept, I'm just going to pick one of these points, substitute them in there, and get my answer. So I'm just going to go with b. So if I substitute b in here, that's going to be 12. It's 5 over 3 times 1 plus c. And if I just do 12 plus 5 over 3, that gives me c as 41 over 3. So my final answer is y is equal to minus 5 over 3x plus 41 over 3. It's not very clear there, but that's what I'm supposed to write, 41 over 3. So, looking at this one here, now it can seem a little bit harder because it's got negatives in both, but you just have to take a bit of care with the negative. So again, if I start with this one here, we have x and y, exact same approach. So I'm going to take b away from a, so the gradient is going to be negative 2, take away negative 10 over negative 1, take away negative 3. So that becomes that, and that becomes that. Okay, and then that essentially is going to be 8 over 2, which becomes 4. So that's my gradient done. Y is equal to 4x plus c. And to find the intercept, I just substitute one of these points in. So if I just go with b, that gives me that. And if I move that over, that just gives me a positive 2. So my final answer is y is equal to 4x plus 2. And again, hopefully you've pressed pause and had a go at the example on the right. So I'm going to take b away from a. And for the gradient, that's just going to be a case of, so we have x, y, and that's going to be negative 2, take away negative 11, over, for the x, that's going to be negative 5, take away negative 2, so that becomes minus 2 plus 11 over minus 2 plus 2, which is 9 over minus 3, and you can see that line's going down, so it's got a negative gradient, so the answer here is negative 3. So the gradient is actually negative 3x plus c. Now I'll just substitute one of these points in. So I'm going to go with b again. So that's going to be that. Take away 5 times. Let's put that in actually. So that's minus 2 is equal to 15 plus c. And if I subtract 15 from each side, I get negative 17 is equal to c. So my final answer is y is equal to minus 3x minus 17. So looking at this one here, now sometimes you won't have the graph drawn for you like it was on the previous one, but we don't really need the graph drawn. It's the exact same approach. We just pick one coordinate, we subtract it from the other one. So with this one, again, we start off by finding the gradient. Now you pick whatever point you want to subtract. So this time we could do a take away b. And then at the bottom, you have to do the same. You have to do a take away b as well. Okay, just remember that. If you do b take away at the top, you have to do b take away a at the bottom. So we have x, y. Again, the exact same approach works here. So minus 11 minus 1 over minus 2 minus 2. So that's minus 12 over minus 4, which is 3. So y is equal to 3x plus c. I just substitute one of the points in now. I'm going to go with b. So I know that c is equal to minus 5. So my final answer is y is equal to 3x minus 5. So again, hopefully you pressed pause and had a go at this example on the right here. So depending on which way around you did it, you would get the exact same answer either way. I'm going to go with a take away b and a take away b here. So that would then, for me, become minus 4 minus 9 over minus 6 minus 8. So that becomes minus 4 plus 9 over minus 6 plus 8, which is going to be 5 over 2. So y is equal to 5 over 2x plus c. And now I just substitute one of these coordinates in. So I'll put a in. So minus 4 is equal to 5 over 2 minus 6 plus c. So that should be 5 over 2. So if I do 5 over 2 times negative 6, that becomes negative 15. And if I move the minus 15 over, I end up with 11. So y is equal to 5 over 2x plus 11 is answer here. So here's some practice questions. Press pause now and have a go. I'm about to put the answers up now. Here are the answers. Mark your work. And that is the end of this video. If you would like some more practice, I have got a worksheet linked down in the comments below over on my website. And if you found this video useful, I've got loads of other content like this on my channel. Do check it out.